Okay, so if you are having molar volume of a gas in your exam, this is how you will perform it. You need to find out the molar volume of a gas at STP. You write two main objectives, then let's see the apparatus. In this experiment we are going to use measuring cylinder, which is of 100 ml, thermometer to detect the temperature, this one is crucible tongue right here, 1000 ml beaker which will be on your table, a scissor to cut the piece of magnesium according to our requirement. This is a piece of magnesium and the brown color is copper. You see, that's copper and that's a piece of magnesium. We require to find the mass of magnesium in this experiment. This is the barometer to find the pressure. Alright, that's 6 molar HCl as a chemical, and we have a distilled water. The last thing in here is an analytical balance or digital balance, which is required to measure the weight of the piece of magnesium. So let us begin. First of all, you need to find out the mass of the piece of magnesium. It should be in between 0.07 to 0.09 gram. Make sure it does not exceed from 0.09 gram. So we're going to weigh it in the analytical balance. Make sure it's 0 in here. Put it up there. This says 0.078. So you will copy it down in your copy. 0.078 is the mass of magnesium. And I'm going to begin. This one, we are going to use copper to hold the magnesium down during the reaction. Otherwise, magnesium will lift up. Here we go. I just took the copper and surround around the piece of magnesium. Wants to make sure that copper hold the magnesium while the reaction is going on. This looks like this now. Now I will fold it up a little bit like that, kind of ring. Okay, and then you will take 700 to 800 ml tap water in the beaker. I have a beaker of 1000 ml here and it's almost 800 ml tap water. Okay, now you have the piece of magnesium there. Dirty? Too much. No, it's fine. So now you'll take the piece of magnesium and drop it into the water. And keep it in the center so that you can place the measuring cylinder over it. The next thing you need to do is take almost 15 ml hydrochloric acid, which is 6 molar hydrochloric acid. You need to take 15 ml into the cylinder. Remember, even if it is 16 or 17 or 14 ml, you will, even if it is 16, 14 ml, it's fine to use that. Going on with the hydrochloric acid, going to add 15 ml into the measuring cylinder. We have got almost 14 ml. That's almost 15 ml hydrochloric acid into our cylinder. Okay, so if you feel that the water is exceeding from the limit of 700 or 800, you can drop some water into the sink. Yeah, Now it seems to be closer to 700, so it's fine, we can use it. Now we have 15 ml hydrochloric acid into our cylinder. Now I'm going to put distilled water to make it up to the mouth. While you're putting this distilled water, it is recommended not to put it in a complete straight way, rather than tilt it and start adding water in it. You will add water until the water gets completely filled the cylinder and the water layer looks like this. Now we'll take a small piece of tissue, fold it 3 to 4 times and then put it out there, and then we're gonna make this cylinder over the magnesium which is inside the beaker to let hydrochloric acid react with the piece of magnesium, which will form hydrogen gas and magnesium chloride. Magnesium chloride will stay in the water, whereas hydrogen gas will be captured by the cylinder. Okay. Make it double. That's a piece of tissue there. I'm going to place it up there, and after placing this tissue, I'm going to quickly put the cylinder inside the beaker and remove the tissue by the crucible tongue. There we go. We place the tissue up there, bring it upside down, take the crucible tongue in hand, bring it inside the water, remove the tissue paper and place it over the piece of magnesium. Now you are starting to see some bubbles are coming. This is of hydrogen gas. Visualize it like that. In this reaction, copper is just holding the piece of magnesium down there. The copper is not going to react with hydrochloric acid. Only the magnesium will combine with the hydrochloric acid, forming magnesium chloride and the hydrogen gas, and the gas bubbles you can already see inside the cylinder. At this moment, you can add the thermometer to check the temperature into the beaker and leave it. You're gonna use, to measure the pressure, you're gonna use this device we called barometer. It's right here. You will see the black digits out there with the gray stick pointing towards, and there is, this is how does it looks. Fine. But remember that this barometer is showing the unit millibar. You are supposed to write the reading in your column in millimeter mercury. For that, you will change millibar into millimeter mercury by dividing it from 1.333. So if you see, it says that almost 1018. You can see that. Can you see that here, Shabab? It's the black digits and the gray line. Take a look on. Okay, so it's supposed to be closer to 18, 10, 18. This is in millibar because the unit is here is millibar. You're going to convert it into millimeter mercury. Conversion factor normally is given. If it is not, you just write 10, 18 and divide by 1.333. It will automatically convert into millimeter mercury. Now you're going to wait for this reaction to finish. And how will you know the reaction is finished? Once you see no bubbles coming out of the liquid, it means the reaction is finished. It means all the magnesium has been used. Okay, so now as we can see, there is no bubbles coming out. That means the reaction is finished. That means the magnesium, which was we took it from the balance 0.078, has been completely utilized, and the copper is still there. Now it's the time for us to take the observations. Firstly, the thermometer, you will take it out and take a close look. What is the value in the thermometer? This thermometer is in Celsius, and you require to write the unit in Kelvin. So remember, whatever you see Celsius here, you will add 273 in it. So it says 24 Celsius for me. Now you will add 24 plus 273, and whatever the value is, you will write it down in the Kelvin. Now we are going to talk about the pressure, which is one of the very important thing in here. This, by the barometer, we check the pressure of atmosphere. Now we required actually in our table the pressure atmosphere right here in the second column. You can see it's over here through the barometer. That's atmospheric pressure. Remember, you need to write it in millimeter mercury, and most of the time the conversion factor is given. Even if it is not given, the conversion factor of millibar to millimeter mercury is right here. 1 millibar is equal to 0.7500 millimeter mercury. Now, once you are done with the atmospheric pressure, we're gonna talk about what is the pressure of water. You see, in this cylinder there are two things majorly. One is the hydrogen gas and the other one is water. We are targeting the pressure of hydrogen gas to fill in this column. For that, first we want to make sure that we deduct or subtract the pressure of water from the atmospheric pressure. To know the pressure of water, which is on the first line in the column here, you need to see the jadwal, the table, right at your table. This table will be provided at your location where you are supposed to do the experiment. And you see, this is the pressure of water at different temperature. These are the different temperatures, and corresponding pressure of water in it is written on the next column. So for us, the temperature was 24. Okay, and the pressure of water at 24 Celsius is supposed to be 22.4. So this 22.4 will be written in the first line of this column, pressure of water at TH, 22.4. Here it is already written atmospheric pressure we took from the barometer after changing the unit. Now, the pressure of hydrogen can be achieved by pressure of atmosphere, which is over here, subtract the pressure of water, which is up there. So over here you're gonna have deduct the pressure of water, and then you will get the pressure of hydrogen gas in here. Now we are going to talk about one of the important thing, which is the volume of the hydrogen gas. Remember, the volume of hydrogen gas, they want you to write in liter, and we are having an ml cylinder. So first let us begin with how to perform the observation over here. You can lift the cylinder according to until the mouth of the cylinder is still dipped inside the water, and then you can have a close look by coming down to your eye level exactly to the layer, and can expect this is 70 right there, so almost 79. This says 79 ml. Remember, when you will write in your observation column, you write 79 multiplied by 10 power minus 3. We are converting into liter. Thank you.